All right, so we're going to start off with a little bit of review, talking about polygons, which we started off one of our sections at the beginning of the year. So what do we remember about what is a polygon? It has to have straight sides. Yeah, it has to be closed, right? And can't have any curves, so like this is not a polygon, right? You also can't have something that's not closed. It has to be completed. Convex versus concave. You remember the difference between the two?
Yeah.
Yeah, concave like
it's like a cave,
right? So if you look at one of the points, we say it contains a point in the interior. That's what makes it concave versus convex. Almost everything we work with will be convex, but occasionally we'll see a concave polygon. All right, well, we want to explore our interior angles. Okay, so polygon interior angle sum. So let's start with a triangle. We know how much a triangle adds up to, right? This is 180 degrees. Okay. So if we take a quadrilateral and we're going to extend the diagonal from one vertex, we end up with...
Is that 3D or is it like...
No, it's one shape. The red line is just a diagonal. I know. It kind of looks like
the hexagon looks like a pyramid.
So here we have two triangles inside the quadrilateral. We might need, I probably should have mentioned a calculator. You're probably going to want. So that means quadrilaterals always add up to 360 degrees. Okay. If you have a pentagon, how many triangles are formed from extending from one vertex? 3. 3 times 180. 540 degrees. So what we're noticing, the more sides we have, the bigger and bigger the interior angles add up to. How about a hexagon? Now, how many triangles?
720.
We have 4. So 720.
How do you know that?
Well, you can grab a calculator. You can have your calculators now. Okay, so if we don't remember the names of the polygons from first semester, make sure you revisit them, okay? Most of them you should remember.
Oh, that's why I ended.
No.
No, it's maroon. Oh, thank God. Woo.
I think it's gold.
It's maroon. No.
No, it's gold.
Whoa.
It's gold because
What's
it has
gold?
gold.
The wheat?
Yeah.
Because we finished with
Yeah, it's gold.
Maroon.
So
We
no.
started gold.
Johnny.
Oh, Saturn.
Johnny's
I
gold.
wrong.
Okay.
Saturn is offset.
Where's Saturn? What?
Johnny boy.
So what's
Go lose your gold.
But I already had my...
How's it going up there in the
I
floor?
hate omega-3.
Okay, everyone, focus. So let's take a look at this chart here. If we have a triangle, we already know this. This is 180 degrees. We said a quadrilateral had 2 triangles. So that was 360. You remember back, a pentagon had 3 triangles. So that was 540.
720.
This had 4 triangles. Okay. So without looking at a heptagon, how many triangles would you have?
5.
You would have 5. And then you would have 5 times 180.
We'll just write that. I'll do it right.
Yeah, that's fine. What is this thing here? You can multiply it. All right. If you have an octagon, how many triangles would you have?
6.
6. So it would be 6 times 180. If you had a nonagon, there would be 7. So 7 times 180. 10, you would have 8. Okay, so that's what I wanted you to recognize. What will be the formula for an n-sided polygon? So if there are n sides,
Wait, what happened to 9?
we don't.
Wait, what?
Why did we skip 11?
Wait, why would we skip 9?
Shh.
What is n minus 2?
We did not skip 9. None got us here. Oh, we don't do the 11-sided.
And then n minus 2 times 180.
Wait, why minus 2?
So if we look at the pattern, what's the difference
Two.
between the number of sides? It's always going to be minus 2. So if I said it was a 27-sided polygon, it would be 25 times 180. Okay, so here's our formula, or 180 times n minus 2. We know it doesn't make a difference what order we multiply. So S stands for sum, and n is the number of sides. Okay. All right, so find the sum of the measures of the interior angles of each convex polygon. So the sum is going to be what?
14 times 180.
14 times. Yeah, this one I want you to multiply it out. So that's why I said you'll want to have your calculator. I'm going to grab mine. Well, make sure you charge it.
2,520 degrees.
2,520 sounds good. Okay, 8x and then GON. So we don't know what x is. We just know this is what n is being replaced with. So I'm going to have, it's going to be 8x minus 2 times 180. So we're going to, what are we going to do for this? We're just going to distribute. So 8x times 180. 1,440x minus 360. So 8x is the number side, so 8x minus 2 times 180. All right. Find the measure of each interior angle. Yeah, we're just like, because there's nothing, we can't do anything else with that. Okay, so first of all, how many sides do we have? 4. Quadrilateral. A quadrilateral always adds up to 360. So if it's a quadrilateral, right, it's going to be 4 minus 2 times 180, which is 360 degrees. You'll get used to it because this whole chapter is going to focus primarily on quadrilaterals. So if it's quadrilateral, just remember 360. So what do we want to do with these?
Set them all equal.
Good. So we're going to add all these together. So we. What's that?
Why is it
Which where?
the side? Like this,
S
4
stands-
minus 2. Yeah.
Sum.
Oh, sum.
Sum. There's 4 sides. 4 minus 2 times
But why
180.
minus 2?
That's the formula. Right?
Oh.
Minus 2 times 180. So I have 2x plus 2x plus x plus x. I want to make those all add up to 360. Good, makes sense. So what happens? We combine all these. What does that give us? Plus, what is it? 6x. Wait, not quite. So x equals 60.
Oh, I'm so stupid. But it's 6.
Not your fine. Okay, so measure of angle A is 60. B 120. C is.
So wait, why didn't we need the formula for that one? We just.
Okay, so you don't need the formula necessarily. Like I said,
It just helps.
What if it was a heptagon? You would want to go back and figure out like how many sides. 7 minus 5 times. But quadrilateral, we're going to be using a lot. Okay, so you should just remember that it's 360. But sometimes, like here, this is a what? How many sides do we have? 6. So this is a hexagon. So what would the sum of all the angles be?
8.
6 minus 2 times 180, right? That's our formula because we need to know the more sides we have, the bigger the sum of all the angles are going to be. So 4 times 180 was 720. Okay, so now I'm going to add, well, I've got two 2x's. And how many of the other ones? 4. So rather than adding them all up, I think it's easier just to multiply. Right? So all of these 6 angles have to add up to 720. Okay, so let's go ahead and solve. Let's see what we get. Did we get X here?
X equals 15.
Good. And then what are the... Excellent. Okay, so we get X equals 15. Yeah, and 30 for 2 of the angles and 165 for the other 4. Okay. All right, regular polygon. Remember regular? Oh, did I go too fast? You got it? Did you get it, Sophia? Oops. Okay, regular polygon. Again, this should be review. First of all, it has to be a convex polygon. That, what do we know? All the sides are congruent. All of the angles are congruent. Is there another way we could describe that? If the sides are congruent, what do we call that?
Equilateral.
Equilateral. And all the angles equiangular. Okay. So here's a regular pentagon. And so what we want to do is we want to investigate what would each interior angle be in this regular polygon. How would we find that? Do we know what all of them added together have to be?
Yes.
What's the sum?
3 times 1.
Right, 5 minus 2 times 180. So all of the angles, right? All 5 angles add up to 540 degrees.
So 540 divided by 5.
So if we take that sum, if I want to find one, so each interior angle will be 540, right? So if all of them are 540 and there's 5 angles, does it make sense why we would divide? And that gives us 108. That means each and every angle is 108 degrees for a regular pentagon. Of course, it's going to be different if it were a regular octagon or a regular decagon. 10 sides. Okay, so can we come up with a formula to find the measure of one interior angle of a regular polygon?
S over N.
Okay, so S over N, or we could do N minus 2 times 180 divided by N. Okay, so what if I gave you the interior angle? Can we figure out the number of sides? Yes.
You could like work backwards.
We have to work backwards. So we're going to set 135 equal to. So we're going to set 135 equal to this. Does that make sense? Because if I'm looking for the number of sides, I have to solve for n.
Could you like multiply N to 135?
Mm-hmm. Okay, so if I multiply 135 to n, then what?
Then you distribute.
Okay, go ahead and distribute. What do we want to do? Do you want to subtract 180 from both sides, or does it matter? It's okay. N can't be negative.
Is it 8?
It is 8.
Wait, N can be negative.
Well,
oh, yeah,
no, the
fine.
number of sides. So if I subtract, I'm going to end up with a negative on both sides.
Wait, during the process.
During the process, correct. So we get N equals 8. Right, divide both sides. So if I asked you for the name of it, then you would just say octagon. Okay, how about 156? Same idea, right? 156.
This is the kind of stuff I get right now, but tonight when I'm doing it, I'm just going to be like, what?
Do you ever look back at your notes in that
No.
situation? Why did we take notes?
I wait for them.
Just for fun? I mean, it is fun, but Sophia, do we not have stuff? Come on. Could be worse.
That is not my thing.
It's 2024. Starting off the new
Oh,
year.
the resolution.
New attitude. Okay.
Yeah. Get rid of it.
Like,
Yes.
that was the fix
Yeah, fix your attitude, girl.
Yeah. Put a smile on
I'm
your
doing
face.
great. I'm thriving. You're using this thing.
Okay, go ahead and subtract and then
The
divide.
exact same
Cool. I
problem.
just want it. Done. Is
There-
it 15?
there is a short-
Is it 15?
There's a
You
short-
divide N out.
Well, stop asking. Stop
Did you get
I think
15?
Shelby asked the question.
Okay.
Yay,
me.
so-
Ouch.
Okay, quick question here. What's the smallest an interior angle could be, and what would be the largest?
Well, the smallest is 1.
Yeah, smallest. What's a regular triangle? 60. So the smallest that an interior angle would be 60. How big could it get? What can it go over? 180. Could you have a line? Could you have a straight 180? So your angles are always going to be between 60 and 180.
Okay.
So imagine if you had 179 degrees, that's almost going to look like a circle, right? If you have like a really big angle like that.
But you couldn't have something like that for a triangle because like hypotenuse.
Yeah, you wouldn't have that for a triangle. Okay. There is a shortcut to that formula, and that has to do with our exterior angles. Okay, so we've done some exterior angles. Let's examine the sum of the exterior angles. Okay, so let's start with the triangle. And for these, we're just going to assume these are all regular just to make it a little easier. So from each vertex, I want you to extend one side.
Oh, it's 360.
So here's one exterior angle. Now I'm just gonna go around. So now I'm gonna go to this vertex and I'm gonna extend that side.
Wait, why are we extending?
Because we want one exterior angle at each vertex. So we want to draw the exterior angles at each vertex. We don't want to have them crisscross, so it's just one exterior. Now, if this was an equilateral triangle, each interior angle is 60.
Wait, how do we know it's equilateral?
We're using regular polygons as examples. Okay. All right. What do we know about an interior angle plus an exterior angle? They're supplementary. Do you see how they form a linear pair?
Yeah.
These two. Okay. So if this is 60, what would each exterior angle be? 120, 120, 120. So my sum would be.
Sum always going to be 360.
That's what we're trying to investigate. So 3 times 120 is 360. Okay, so exterior angles in a triangle add up to 360. Let's take a square. What are all the interior angles? 90. So here.
Could you also make the arrows sideways?
Sure.
How do you know which one the arrows?
It doesn't matter. Just pick one. I like to just start from one direction and kind of like go around. Right. So if this is a square, all the interior angles and these exterior angles would be the same. The sum here
4 times 90.
which is
365. What? 360.
360, right? 4 times 9 is 36. Okay, hexagon. So what are we noticing? Even though I increased the number of sides, the exterior angles stayed 360. So here I'll start. Okay, to save time, I will tell you that each interior angle
Oh, yeah.
it's not mine. It's definitely not.
Is it in the first?
Mine's on silent.
My phone's over here, clearly not going
It's in
on.
the first.
No, this is my phone. It's over here. So,
She's a
Mine's on silent mode. Why would it make sense?
How do you know? You put it on silent.
okay, to
What?
save
It's okay, I
time,
believe you.
to save time,
Shelby's the only one. who
each
knows.
interior angle is 120, so each exterior angle
Okay, that's not that.
60.
Sorry.
Dumb.
Maybe it's that I should have described myself.
So,
Wait,
so these are all 60 degrees. I just said, just to save some time, we could go through the whole process.
Oh, no.
So 6 times 60 gives us 360. Bless you. So, no matter how many sides we have,
Always 360.
the sum of the exterior angles is always 360. So that 360.
Yeah.
It shows you.
No.
Okay, now what if we want to find one exterior angle of a regular polygon? 360 divided by n. Okay.
I think by one. Yeah.
All right, we want to find the measure of each exterior angle and each interior angle for a regular polygon. So we'll start with pentagon.
5
Okay, so
minus 2.
well, okay, we could do that, but it's actually easier to find the exterior angle first. So let's do exterior. We're just going to take 360 divided by
5
n. Pentagon has 5.
equals.
How do we know that?
Well, it's a pentagon.
Oh, it's not a size.
72.
Now, what did I tell you about?
Is it what n?
Pentagon is 5.
Pentagon is 5. 360 divided by 5 is 72. Now, I can either go back to the interior angle formula, the n minus 2 times 180 divided by n, or what do we know about interior and exterior angles? They always add up to.
What if it doesn't
No,
go?
360.
It can
Wait,
be a decimal,
wait,
right?
360.
360, I won't. It can
What?
be a decimal.
It can. Yeah. So remember, interior plus exterior equals 180. So if I'm finding the interior angle, I can just subtract. So what does that give us? 108.
How many sides is in a dodecagon?
A dodecagon, n equals 12. Okay, so to find an exterior angle, 360 divided by 12. What does that give us? 30. And then what's our exterior angle?
Interior.
Interior angle, sorry.
180 minus 30.
180 minus 30, which is 150. Okay, last example. Okay, so here we have a 20-sided polygon. We want to find the measures of the interior and exterior angles. So same question as the last one. So what would we do? 360 divided by 20. So that'll give us an exterior angle. So this is our n.
The number of sides is always n.
Mm-hmm. So 360 divided by 20, 18. And then an interior angle. Good. Okay, again, now 18 is n, which actually is like the opposite of the last one, right? It's 20. So the exterior angle is 20, which makes the interior angle